Hello everybody. Today we're going to be starting lesson 1.2, and I figured that this time we could actually go over some of the warm-up because I know some of you are still struggling with a little bit of order of operations, so we might as well go over this a little bit and then we'll get into the lesson. Let's do the first one, at least definitely the first one, maybe probably the first two together. So we're going to look at doing grouping symbols here first. 2 plus 7 is 9, and we're going to multiply that by 5 plus 11 minus 3 squared. And the next order that we do is exponents. So you got to square the 3, which becomes a 9. 5 times 9 plus 11 on the outside. And then now we're done with both of those, we get to do some multiplications. So we multiply these together, get 45 plus 11 minus 9. Now we go from left to right. We have addition and subtraction. So we get 56 minus 9. So that's going to be 47 as your total. And number 2, we're going to subtract these two numbers because it's inside of a square root symbol. So when we subtract them, we get 121. So it's square root of 121 plus 14 divided by 7 minus 12. So we can still do the square root. That's still inside of a grouping symbol. That turns out to be 11 plus 14 divided by 7 minus 12. We have addition, division, and subtraction. So we're going to do the division next. It's going to be 14 divided by 7, which is 2. So 11 plus 2 minus 12. Now left to right, we get 13 minus 12, or the answer of 1. Number 3, I'll let you do on your own. Just remember you need to divide first. And I know it happens to be a decimal. So it's 0.444, so on. So I'll start it with you, but after that, you should be able to finish that one. So you can do that on your own time. Pause the video if you need to. Okay, 1.2, we're going to talk about what the difference is between a relation and a function. You've probably heard those words before, and hopefully you've actually used this before, but it's the difference between a relation and a function. For our first example, normally we do, I usually get 9 students, and I'll do the shoe sizes, get your shoe size and your height. But for right now, I got some sample data. Most of the students here are within, about 10 inches from like 60 to 70 or so in height, and then their shoe size goes from anywhere between like 6 to 10. So we're actually going to be plotting these points onto this graph to see what it looks like. The y values is your height, so let's label these. Height. And then the x values are shoe size. And let's see what we have to go by. So the height, we have to go from 60 to 70. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's pretty good. We're going to start at about 60. So I'm going to put a little break in the chart here and say that this number is 60. And I'm going to go up by ones. I think that will work okay. So 61, 62, 63, 64, 5, 6, 7, 8, 9, 70. And that should be able to take care of all those numbers. And then to go over the shoe size, we only need to go about like 5 or 6. So we're going to start and go at, let's see, probably 5. So let's put a break this way, and we'll start at 5. And can I go every other one? 6, 7, 8, 9, 10. That should work. Oh, that's a 6. Because we do have an 8.5 up here, up top. So let's plot these points here. Also, I mean, before we do that, actually, we should probably go over the order pairs. What we're going to do is we're going to take all these numbers here, and we're going to write them as order pairs. I'm not going to do them to all of them, but an order pair is an x value that's followed by a y value in parentheses. So I'll give you an example. It looks like this, x comma y. You probably seen that before, hopefully. So if we do that with the points up here, we have X for shoe size and Y for the height. So if I were to make the first one into order pair, it would be 10, 68. And if I were to plot that point, I would go over to 10, I would go up to 68, and then put a dot. I'm going to do a couple more. So we could do 7, 63, and that would be 7. 63 would be right about here. 6, 62. I'm just going from one point to the next. 662 would be right here. And I'm going to keep filling this out, but I'm not going to write out all the order pairs here. 8.5, so that would be right here at 66. So right here. Then we have 1069, which would be here. We have 968 there. 663. 865. Oh man. And we have 1070 all the way to the top. So that's our data. Just plotting points, just practicing plotting points. We're actually going to come back to this in a little bit and talk about the data in association with the relation or function. But for right now, you should be able to interpret the data by putting it as an order pair and being able to plot it on a graph. So let's talk about these variables. The independent variable, which one is it, the x or the y? The independent variable is the x value. We're the ones plugging in the x values most likely. We plug in an x value, and depending on what the function does, it pops out a y value. So the y is usually the one that depends on the x value. An independent variable is also called the input. It's what we put into the functions. Usually the x value is what you put into the functions. So it's called the input. Dependent is called the output. The y value is what you get out. So let's actually talk about the difference between a relation and a function. So a relation is very simple. It's just any set of order pairs. So all the order pairs that we were writing down in the previous example, all of them combined would just be a relation. But to be a function, you have to have something very specific. So it is a relation, but it's a little bit more than just that. So maybe remember how to test whether you have a function or not. So in this particular case with ordered pairs, you don't have any repeating x values that give you a different y value. That's usually what we're looking for. Do the x values repeat and go to a different y value? So let's look at this little diagram down here. A relation can literally be anything that you want, right? Any set of ordered pairs. So we can make whatever we want. 1, 2, 2, 7, 2, 9, 5, 11. I'm just putting a bunch of ordered pairs. 6, 13. Let's do 1, negative 3. All these, combined as a set would be a relation. To be a function, though, we cannot have the same x values go to a different y value. So in this particular case, I actually created something that's not a function. If you look here, the 2 goes to 7 and a 2 goes to 9. That cannot happen to be a function. So this set cannot be a function. So let's create a function as well, something that will work. As long as we keep changing the x values, we should be good. So I could do 1, 2, 2, 7, 3, 9, 4, 10. So you can keep going, right? As long as we keep changing that x value, it doesn't matter. So we can actually repeat y values. So as long as we do different x values, it doesn't really matter. So what if I did, like, let's say 12, comma 10. Would that be okay for these two? Absolutely, as long as the x values are different every time. So anything you can think of as a relation, but there's only a smaller subset of things that qualify as a function. Vertical line test. Maybe you've seen and done this before. This is specifically used with graphs. So the way we just did it was with ordered pairs and testing whether or not the x values repeat. The vertical line test is with graphs. This determines if, when you have a relation, determines if it actually is a function. So hopefully you understand what the vertical line test is. Hopefully you used it before. If a vertical line can be drawn on the graph and it intersects the graph more than one time, then it is not a function. Some people like to use their pen and kind of go across the paper, and if it intersects more than once, then it's not a function at any point in time. I usually practice this by just drawing vertical lines on it to see if it crosses at all. So that's actually a very easy way to test if graphs are functions. We're going to do an example 2, and now we're going to have two separate things. We're going to do the vertical line test on some of them, and then just do the test for functions by looking at the x values. So which of these is a function? Circle the answers below, and we'll explain why. So if we look at A, just looking at the ordered pairs, really the y values don't matter. What really matters at first is looking at the x values. Do any of the x values repeat? Yes, they do. We have 3, 8. We have 3, 6. So do these two go to different y values? They absolutely do. 3, 8, and 3, 6. So that must mean that it is not a function. Why? We're simply going to say x values repeat. I don't want to say a really long, exhausted explanation, just something really short. It's not a function because x values repeat. Same thing here with part B. We look through and see 1, 2, 3, 4, 5. They are all different, so it is a function. No repeating x values. Sorry, it's hard to write on this. All right, now we're going to try our vertical line test because now we have graphs. If we go to part C, if we can ever draw a vertical line and go through more than one particular point on the graph, then it's not a function. As you can see, as I draw multiple vertical lines, it goes through more than once. So this first one goes through here and here, and similarly to the other ones, they all go through twice. So as soon as you draw a line anywhere and it goes through more than one time, it is not a function. And I'll simply say as an explanation that it fails the vertical line test. And we can shorten this to say VLT. Okay, the last one for our graph, if we draw vertical lines through, it happens that no matter where you draw a vertical line, you're never going to hit more than one time on the graph. So this is a function. It happens to pass. VLT. Vertical line test. Only ever hits once. Okay, so now let's actually go back. Example 1, it says, looking back, is our shoe size and height information, is it a function or relation? So let's go back here. So would we categorize this as a function or a relation? You can actually look at either one. You could look at the x values and see if it repeats and go to a different y value, or you could do a vertical line test because we have both things. Let's talk about the vertical line test first. Do you see any place where you could draw a line and hit more than one place on the graph? because I see two places that happens. All the way over here, straight down, hits 3 places right there, and over here it also hits 2 places. Let's back it up a little bit, draw a straighter line. So it hits twice here and 3 times here. So this is not a function. And if we look up here, let's see if anything repeats. We have 10 going to 68. We have 10 going to 69, and we have 10 going to 70. So all 3 of those make it fail. We also have 6s. 6s go to 62, and the 6 goes to 63, which is exactly where it fails on the graph. So it fails in both cases. And it should. They should both make sense. They should both fail. So is it a functional relation? It's a relation. And you can say whatever you want as far as is it failing the VLT or is it repeating X values. I'll just say it's easiest to say fails VLT. That's a completely acceptable answer, just as an explanation. Our example 3, we only have one more left. So this one turns it up a little bit to make it a little bit more difficult, because we're so used to seeing and looking at the X values and determining whether or not you have a function. This one is actually slightly different in how it's worded. If you look at part A, look how it's worded. It says, is y a function of x? When it's worded this way, it's kind of telling you what you need to look at to see what repeats. So it kind of takes the original rules and throws out the window, and it's saying, hey, okay, if I word it like this, is y a function of x? You look at the end part, x, and that's what it's asking you to see if it repeats. So we're going to look at the x numbers, 3, 4, 5, 6, 2, 7, 11, 14, 0. Do any of them repeat? No. So this means when you see this, see if x values repeat. Whoops. Erase that. And we already looked at it, right? Did anything repeat? I don't think so. So this is not repeating, so that means that is y a function of x? Then we would say yes, it is. It is a function of x. If you look at part B, they reverse it. Is x a function of y? That means in this case, we're going to see if the y values repeat. Oops. So we look up here and see. Now we're looking at the y values. 11, 15, 19, 27, 11. Oh, here we go. Found a repeat. The 11s repeat, and 1 goes to 2, 1 goes to 3. Anything else repeat? The 19s also repeat. 1 goes to 0, 1 goes to 5. So is x a function of y? No, because we're looking to see if the y values repeat. So if it's ever worded this way, you always want to look at the row of whatever comes last. Is x a function of y? So we look at y. So we are on the huddle, and the rest of it should be up to you to do. I'm trying to see if there's anything that needs to be talked about, but I think you should be able to do the rest on your own. And if you have questions, we can answer them in class. So that actually is the end of lesson 1.2. Hopefully it wasn't too difficult, and we'll see you in class next day.